All right, so for today's worksheet, you have mixed problems. And usually I find that this is what gives students a lot of issues, is when the problems are all mixed up. So it's really important when you work in these kinds of problems to be able to determine what you're starting with, where you're trying to go, and to be able to recognize the roadmap, the series of steps on your railroad tracks that you're going to take in order to go from that known to the unknown. So I have a couple of practice problems here to show you how to go through the steps to determine how to get from your known to your unknown. So the problem states, in a very violent reaction called a thermite reaction, aluminum metal reacts with iron 3 oxide to form iron metal and aluminum oxide according to the following equation. What mass of aluminum will react with 150 grams of iron 3 oxide? So as always, let's start with our knowns and our unknowns. So our knowns is 150 grams of the Fe2O3, the iron 3 oxide. And what we are solving for is mass of aluminum. So what we have here is grams, 2 grams. So that's problem type 4. And the map for that is going to look something like this, where you're going to have the grams of the known. I'm going to abbreviate known as K. And then from there, we're going to put in the molar mass of the known. So here is going to be molar mass. And whenever we use the molar mass of the known, we always put that with 1 mole of the known. And then the next thing, because remember, it's important that you can get those grams into moles, because that is what's going to allow us to go to the mole ratio. So the mole ratio is what we're going to use next. And we have here, nice little mess up. See if I can't get that to erase. So we have here 1 mole of the Fe2O3, and we have 2 moles of the aluminum. So that's going to be the numbers that are used in our mole ratio. The numbers used in the mole ratio always come from the balanced reaction. So we're going to have the mole ratio of the known and the mole ratio of unknown. So I'm going to abbreviate that UK. And then from there, now we can do the molar mass of the unknown. And once again, we always use 1 mole of the unknown and then the molar mass of the unknown. And then you can solve the problem. So this is your map that you would use anytime that you're doing a mass-to-mass problem. So if we go ahead and put in a little bit more space, we can go ahead and solve for this problem. And the first thing I'm going to do is I'm going to solve for the molar mass of the iron 3 oxide. So that consists of iron and oxygen. We have 2 ions of iron, 3 of oxygen. The mass of iron from the periodic table is 55.85. And this is going to be, oxygen is 16. And if we calculate that out, we're going to get 111.70. and then 48 even. Add that together and you get 159.70. All right, so let's go ahead and put in all of our information. So we have 150 grams of the iron 3 oxide, and we're going to put in our molar mass, which is the 159.70 grams of the iron Fe2O3, 1 mole of Fe2O3, and then we're going to put in our mole ratio. So let me go back up to my equation. So I'm going to have a 1 for the iron and a 2 for the aluminum. So for every 1 mole of iron 3 oxide, I'm going to have 2 moles of aluminum. And then let's put in our molar mass of aluminum. So we're going to use that 1 mole of aluminum, and then the molar mass, which is 26.98 grams of aluminum. Once again, we put this into the calculator and we come up with 50.7 grams of aluminum that are used for when you use 150 grams of the iron 3 oxide. All right, I have one more example to work with you. So once again, we're going to start off by writing our knowns and our unknowns. So we were given 0.905 moles of aluminum oxide, and we are supposed to solve for our unknown is the mass of iron that's produced. So what we see here is that we have a mole to mass problem. And so what we do here, we're going to start off with our moles. Of our known. Now this problem is a little simpler than our first one because we're already in moles. So if we're already in moles, we can go straight to our molar ratio. So let's go back to our balanced equation and see what those numbers are. So for aluminum oxide, it's an understood 1 and the iron is a 2. So this is going to be the mole ratio of the known and mole ratio of the unknown. And from here, we can go ahead and use the molar mass of the unknown. So for every 1 mole of the unknown, we have a molar mass of unknown. So that's our map that we would use for this kind of problem. So let's go ahead and solve it. So we're going to put in try that again. There we go. Oh, there we go. And then we're going to put in that mole ratio. So we said there was 1 mole of aluminum 2 oxide. Remember, once again, I'm getting this from the balanced equation, the coefficients on the balanced equation. And we're going to have 2 moles of iron. And then now we're going to put in that molar mass. For every 1 mole of iron, there is the molar mass of iron is 55.85 grams. Once again, I've gotten that number from the periodic table. Plug and chug, and you will see that the answer is 101 grams of iron. All right, so what you're going to do is a worksheet, and it's all the problems are mixed up. Notice I have a link here for your exit video topic. This is due at the end of class today, which is about 10:30, and it shows you what problems you need to do for what, depending upon your class period. This is so important, ladies. Not all reactions are balanced or given. All right, you can skip number 3. No known was given in number 3, so you can just skip number 3. But don't forget to, as you're going through these problems, to make a roadmap. Determine what kind of problem it is. What are you going to have to put in there? So go back to the video and see if am I starting in moles? Am I starting in grams? Am I trying to get to grams? Am I trying to get to moles? So to help you determine what needs to go next into your railroad tracks, you're either going to use coefficients from your balanced equation, or you're going to be using the molar mass of that compound. That's it, ladies. That's the only 2 things you're going to be using in all of these stoichiometry problems. All right, ladies, that's it. If you have any questions or problems, please feel free to email me or Skype me.